The moon is one of the most familiar things in the night sky. It rises over cities, villages, coastlines, mountains, and empty roads. Sometimes it appears as a thin silver curve. Sometimes it looks half-lit. Sometimes it becomes full and bright enough to change the feeling of the night. Today, many of us notice it for a moment, take a picture, and then check the date on a phone. But for much of human history, the direction worked the other way around. People looked at the moon because it helped them understand where they were in time. Before clocks were carried in pockets, before paper calendars hung on walls, and long before a phone could show the date instantly, the moon offered something extremely useful, a visible pattern that returned again and again. The central question is simple. How did the moon teach humans to count time? The first answer begins with the way the moon changes. The moon does not appear the same every night. From Earth, its visible shape seems to grow, brighten, become full, shrink, and disappear again. This happens because of the changing positions of the Sun, Earth, and Moon. As the moon moves around Earth, we see different portions of its sunlit side. To a modern science student, this is an astronomy diagram. But to people without modern instruments, it was something more practical. It was a repeating sky signal. A thin crescent could tell people that one part of the cycle had begun. A fuller moon could show that time had moved forward. A waning moon could signal that the cycle was approaching its end. The moon did not need writing to be noticed. It did not need a ruler. It did not need a temple, a clock, or an official announcement. It appeared above everyone. That made it powerful as a shared marker. The cycle from one new moon to the next is roughly 29.5 days. That is close to what we now call a month. The word month itself carries the memory of the moon. Long before a month became a printed box on a calendar, it could be felt as a return. The moon disappears, returns as a crescent, grows full, fades, and begins again. This is where time becomes countable. One night is easy to feel. The sun sets, the sun rises, and a day has passed. But longer stretches of time are harder to hold in memory. 10 days, 20 days, 30 days, these need markers. The moon gave people a natural sequence that could be watched, remembered, and discussed. A community did not need everyone to own a calendar. People could look up and recognize roughly where they were in the cycle. That mattered because human life needed coordination. A gathering cannot happen if no one agrees on when it will take place. A ritual cannot repeat if no one remembers the right interval. Travel, trade, planting, hunting, fishing, and seasonal preparation all become easier when a community has shared ways to mark time. The moon did not solve every timing problem. It did not tell people the weather. It did not replace local knowledge of seasons, rivers, animals, crops, or climate. But it gave a visible rhythm that could help people organize memory. This is why the moon became more than an object in the sky. It became a kind of public calendar. In many traditions, the beginning of a lunar month was connected to the first visible crescent after the dark moon. Imagine a group of people watching the western sky after sunset. The night is not only beautiful, it is practical. If the new crescent is seen, a new count can begin. That moment turns sky watching into social timing. The moon becomes a way of saying, this period has ended and another has started. Over time, this kind of observation could become more formal. People could mark nights. They could count repeated cycles. They could connect certain gatherings, observances, festivals, or duties to particular parts of the moon's rhythm. This does not mean every culture used the moon in the same way. Some calendars were more solar. Some were lunar. Some combined both. Some relied on observation. Others developed calculation. But the basic attraction of the moon was clear. It changed visibly enough for ordinary people to notice. The sun is also essential for time. The day comes from the sun. The seasons come from Earth's yearly relationship with the sun. Farming, weather patterns, and temperature changes are deeply connected to the solar year. But the sun does not change shape across the month in the way the moon does. Its rising and setting can mark days. Its path can reveal seasons. But for counting a medium-length period between a day and a year, the moon was especially useful. It gave time a visible middle scale. Not as short as a day, not as long as a year. A month-sized rhythm. This is one reason calendars became such an important human invention. A calendar is not only a list of dates. It is a way of making time shareable. It lets a society say when work begins, when rest happens, when festivals return, when obligations are due, when markets gather, and when memory should be repeated. The moon helped humans build that shared structure. But then came the problem. The moon's rhythm is real, but it does not fit neatly into the solar year. A lunar cycle is about 29.5 days. 12 lunar months make about 354 days. But the solar year is about 365 days. That leaves a gap of roughly 11 days each year. Over time, that gap becomes too large to ignore if a community wants the calendar to stay connected to seasons. This is the great calendar tension. The moon is excellent for counting months. The sun is essential for keeping seasons. But the two rhythms do not lock together perfectly. If a calendar follows only lunar months, the months can move through the seasons over time. A month that once occurred in one season can later fall in another. That may be acceptable for some religious or cultural calendars. But if a society wants months to stay close to agricultural seasons, it needs adjustment. This is where human timekeeping becomes more creative. Some societies used lunar calendars. Some used solar calendars. Some used lunisolar calendars, which try to keep lunar months while also staying aligned with the solar year. One common solution is to add an extra month from time to time. This leap month helps bring the lunar count back toward the seasonal year. The Chinese calendar is one familiar example of a lunisolar calendar. It keeps lunar months, but uses leap months in certain years so the calendar remains connected to the solar cycle. Other calendar traditions developed their own methods of adjustment. The important idea is not that every calendar solved the problem the same way. The important idea is that the moon gave humans a rhythm, and then humans had to design around its limits. That makes the moon's role even more interesting. It was not a perfect clock in the sky. It was a teacher of pattern. It showed repetition. It made time visible. But it also forced people to compare different kinds of time: night by night time, month by month time, and season by season time. This comparison helped turn observation into astronomy, memory into calendars, and local practice into organized social time. When we look at old calendars, lunar festivals, crescent sightings, full moon gatherings, or months named and counted across cultures, we are not only seeing dates. We are seeing the long human effort to make the sky usable. And that effort still reaches us. Even if we now use digital calendars, the month remains one of the basic units of modern life. Salaries, bills, appointments, school terms, reports, subscriptions, and festivals are still arranged through monthly thinking. Most people no longer check the moon to know which day it is. But the idea of a month carries an old sky memory inside it. The moon is no longer our main calendar screen, but it helped teach humans that time could be watched, counted, shared, and repeated. So the next time the moon appears above a quiet street, it is worth seeing more than light in the sky. That same changing shape once helped people remember when to gather, when to begin again, when a cycle had passed, and when life had moved forward. The moon did not only brighten the night. It gave human time one of its earliest rhythms.